Alright, this is gonna be unscripted explaining of a rhythm game. Me like I'm using this project which I'm using for a rhythm game tutorial. And so the idea of this is instead of making like an offset that happens on first play because I don't have a menu for debugging and shit. But since I don't want to just like teach you how to make a rhythm game, what I'm instead going to do is I'm just gonna in the full tutorial I'm gonna teach how to do this, like some simple basic thing like this, and then I'll show you how you can use this stuff and turn it into any kind of rhythm game. So like Osu Standard, Osu Mania, basically Relax, Osu Catch, or Taiko, really anything you feel like. So first thing you may notice is a blank sprite. This is very simple reasoning. So one of them is obviously you can make like a change log, whatever. Other thing is whenever you start the project on big projects, which this will obviously become, it can be really laggy and cause offset issues whenever you load it in stuff like the backdrop, backgrounds, or anything with code in it. So I recommend if you make a blank sprite, and this is where you're going to save the project and start it, of course. So first thing I want to show is managing maps. So basically, there's four main components to decoding a map, and it's these four custom blocks right here. These four. This one is used for something else, which I will go into more detail. But first thing, we're just going to go into decoding the current chart. So why do we need to decode a list? Well, the list needs to be decoded into three separate lists, which in the project, well, in the project is these lists. And so it's good to have it decoded like this because, well, when you look in the project, whenever I run it, you see it refills all these lists. I get lag because I'm not in the blink sprite, but whatever. And you see it deletes the items whenever the nodes are hit. And there's, of course, the current chart, which is like the main thing. This is your chart stored in longer lists. So what this is just a string of data. As you can see, this is your time value, your position, and costume. Ignore the metadata list. And so you have over here on item 5, which is what I copied from, you have your time. Over here, item 5, you have your position. Over here, you have your costume or lane or whatever you want it to be. It's just like a buffer extra item. And so in here, that's where I use this sprite is where I'd use that data. So instead of decoding it every frame, we decode it before the project starts, and then we just fetch it from the list, which is really useful and nice. And how this is really just done is we have two iterators, index, which is the item of the list. Oh, let me just hide these other three lists real quick. So index, which is the item of the list. So if index is equal to 1, we're getting this item, 4, this item, 20, this item. And I is the letter of the list. So say we're on index of 4, I of 6. 1, 2, 3, 4, 5, 6. We're on this 1. And this can be done to scan through the different items. And so what we do is we'll take I, scan through these 4 until we reach the comma. Then we basically cut this, paste it into a new list. Then we go past the comma, do it again. Go past the comma, do it again. And so that's how we get our two different data. And this can be done, of course, with the simple method that I use, which is just you decode segment value, which is your string. Whoa. And so basically, what this will do, duplicate. Basically, I'll just replace value with this, and I'll show an example of this iteration happening. So we start off by setting store. Hold on, let me set I to 1. Start off by setting store to a blank value. We check out letter I of this value. It's 9. And so what we do is we set store to letter I, joining store in letter I of this value, which just becomes 9. And so we repeat this until it's equal to a comma, which it's equal to a comma. Well, it changed I by 1 at the end, so here, let me show that again. It's equal to a comma, which we don't add this comma to the list, to the value, and store is equal to this. Then after that, we take the store value and add it to the corresponding list, and we keep doing this over and over again. We have our comma here and a blank value here. This is not a space or anything, it's just a blank value. Bro. Okay, well, apparently that was disconnected from the script. And that's how we decode items into different lists. Next is encoding chart, which is basically saving a chart in the state where we decode it. And it's very simple. We just use one iterator, set index to 1, actually, so that way I don't accidentally delete the list. Okay, there we go, I just loaded it in. We set index to 1, repeat the length of one of the lists, which it's fine if one of them's empty, just we don't want chart.time to be empty. So we're going to do the length of chart.time. So if there's no position, it just goes to the center, and if there's no costume, it just does the default. And so iterate this many times, and basically what we do is we clear the chart.current list and set store to a combination of all these values put together, which of course forms this. Index of chart.time, comma. Index of chart.pose, comma. Index of chart.cost, comma. Set that to store, then add store to chart.current. I prefer not having this long thing go inside the list because it's much more user-friendly for reading. As you know, store is becoming this value, store goes to the list, and you can see the list. Unlike this, it's off screen. Iterate index by 1. No need to iterate it again at the end since you're not using it again. There. And then, of course, later gets decoded again. So it's the same methods reused. Next is compressing charts. We'll get to loading charts later. Compressing charts is a way of storing the chart onto a single item. So if I go to this all charts list, sorry for blinding you, but you see we have all of our chart data, but this time in a single line and separated by a marker, which I used \n, this value right here. And so this section right up here can be neglected. Ignore that. But as you can see here, that's our note data. Separator, note data, separator, note data, separator, note data. Repeats over and over again. So basically what this does is it will repeat the length. We're going to ignore this metadata for now. It will repeat the length of chart.current, which is our current chart. And then what it will do is it will set store to a blank value at the start. And what it does is it will keep on setting store to update joining these values together. So repeat that. And that basically compresses this chart into a single line, which we can store for decoding later. Next is the final part and probably the most complex, loading the chart. Now, this looks complex, so really ignore all of that. Ignore this shit here. So we can remove this, that. Yeah, that's right. Okay, so we're going to start by setting chart.value to our chart. I'm going to remove this extra metadata. It's for part 2, so you don't need to worry about this. It's just useful for something that comes up much later. So we're going to set chart.value to this long ass string. Chart.value is literally, hold on a second. I'm not going to leave all of chart.current right now, but chart.value, literally just the entire thing that I showed earlier. So we start with setting I to 1. We don't use index, just I. And what we do is we'll repeat the length of this value. And so basically what's going to happen is we first check what the current letter of I of chart.value is. If it's a backslash, then we'll run this, then we'll run a check actually and check the next value and see if it's the corresponding value we need. If it is, we'll run a certain script which I'll go into in a moment. If not, which most likely is the case for right now, what we do is we just simply set store, which no, don't set it to I, but my Wii remote. We set store to a combination of store and letter I of chart.value, which sets it to 9. And we'll repeat iterate I by 1, change store, iterate by 1, change store, iterate I by 1, and now this time, what's letter I of chart.value? Wait, alright, the comma. Sorry. So, as we can see on letter I of chart.value, it's the backslash. And then the next letter is N, which backslash N indicates new line. So what we do is we'll add store to chart.current, which updates the new value, loading it, set store to a blank value, and iterate I by 1, so that way we go from this letter to this letter. And then again, we'll change I by 1 again, which gets past the N and onto the next list value. See, it's not that bad. And that's really the simplest part of this. That's just the chart decoding. This metadata part can be ignored for now. Now, wait, what was this from? Oh wait, no, that can just be removed. Now, that is how we decode our chart data. Next is in note rendering. How the hell do we render notes? It's actually quite simple. We use delta time to time our notes. So I'm just going to go right now and go through the basics of how we set up everything. So we start off starting the chart, and of course loading the chart. This sets up the chart, loads the chart, then decodes it. Important, it loads first and then decodes it. Otherwise it's going to decode nothing. Kind of important. Next we reset our counters, then we reset timer. We're going to be timing our notes based on this timer value. Unlike most games where they have like this custom block that's like generate note at X, Y, yeah, and then it like goes to X, Y, whatever, creates a clone. And then when I start as clone, forever, change Y by -4, which works, but here's the problem. I want you to take a long, hard look whenever I put this in a weight 0.2, which is what most people do. and then like a forever loop. Hold on, I need to actually stop infinite clones on. If y is less than negative 100, delete this clone. Alright. So I'm going to run this. Oh yeah, it's a little too fast. Okay, well. I'll do negative 0.5. I'm going to look at this. What do you see is wrong with this? Alright, now, if I keep doing this, it becomes even more noticeable. You see, the notes are not consistent. It's still noticeable here whenever I sit still. Like here, I'll pause. You see it? It's not consistent. And this is because Scratch doesn't run at a consistent 30 FPS. In fact, this is actually 240 FPS. So if I run it at normal 30 FPS, it's even more noticeable. Like, I forgot to, whoops. It's even more noticeable. Look at this. I accidentally clicked flag, my bad. Look at that. You see, just moving my cursor causes enough lag for it to fail. Look at that. So this is really bad. You see, it's really inconsistent. Plus, timing notes is a pain in the ass if you do it like this. Fuck all of that. Instead, we're going to use delta time, my beloved. We're going to start off by setting timer to negative 3000. And this is negative 3 seconds. Negative time doesn't exist, I know. Shut the fuck up. But we offset by negative 3 for playability reasons. Because if it starts at 0, look at that. You only get 1 second of reaction time. You need more than that. Sometimes you might want it to be negative 5 or negative 7. That's alright. It's up to you. Now, whenever we set our time, it's literally just offset by 3 seconds, multiply by 1000, which turns it into milliseconds, which is much more useful. Forget print background, print game, and note hit for now. We're focusing on print.notes, which is our broadcast. Oh yeah, I feel like I should mention this is called a tick loop, where you have one main loop which controls everything, and then you broadcast things to different sprites, that way they can run their scripts. This is very important whenever you do a pen game like this. I'll go into more detail later. So about going into more detail later, I forgot to go over this. So basically what a tick loop does is it will take a long loop with all of our broadcasts, which can be broadcasted in order to control layering. Something else that can be done with layering is printing. Since we print using stamping, we need a way to layer that stamping. So sometimes we'll use clones, and those clones can be layered using traditional layering methods. And because of the way broadcast works, we can use that layering, and the sprite or clone that is in the front will receive the broadcast first. So say sprite 1's in the front, it will receive the broadcast first. Sprite 2's right behind it, it will receive it second. Alright, just thought I should say that. So on print notes, we have a custom block, obviously run without screen refresh. Basically, every single custom block runs without screen refresh in this project. We of course have our favorite iterator's index. And so we set index to 1, item index, and we repeat until item index of char.time equals a blank value. Note, this is really bad. Don't do this. I instead do if y position is greater than 180. The reason why you shouldn't do this is if someone has really low note speed. For example, I set note speed to 1. Look at that. Here, let me actually make the game more playable. Because there's so many notes, it's actually crazy. Like, look at that. I'm sure if someone tried to run this on their school Chromebook like that, it would not run well. Oh yeah, also speaking of things not running well, never turn on turbo mode. Never turn on turbo mode. Trust me on this one. Do not turn on turbo mode. Until we get into later stuff, which there will be a rare case where you do want turbo mode on, never turn it on. Stick to 240 FPS. Another thing, avoid this at all costs. This, obviously. Alright, that's too slow note speed. Looks like shit. Currently, interpolation is really hard to show as to why it's so bad, as we don't have much that's going on. But basically, with any pen projects, you do not want interpolation, as it will blur it terribly and really doesn't look very good. I'll leave a note card up that explains why interpolation is bad, mostly in animation, but can be applied into this situation here. We start off with setting index to 1, and we'll repeat until this value is not either at the end or our Y position is over a position. Yeah, that's normal. And so basically what this does, it'll stop the script if the Y position is over, which we position before this. So we fetch the note data, print the note, and change index by 1. Basically what fetching note data does, it just sets 3 store values to these values, so that way we're not using 2 blocks for so many different things. It's just a lot better. Next is print.note. This here can be ignored for now. We just want to focus on this right here. Of course, we start off by setting our costume, setting our position. I'll get into why we changed the size to 1000, or even if you really feel like it. Okay, I thought I could mesh faster than that, but like, you get the point. A large ass value. There's a reason why we do that. I'll get into that later. You may already know exactly why, but yeah. So we'll just start off by breaking things down. Here, let me just do that. I want the first value. So sort out time minus time. We get 178, which is 178 milliseconds, or 0.178 milliseconds. Note this is a floating point error. Doesn't matter. Now, if we just do this value, say we put this value into set Y position. Look at that. Look at this. Okay, so like you see how the notes, they're timed to 0, 0. So like, say I move this line I have up here to 0, 0. You see the notes are at the position 0, 0. So whenever you hit the notes, they'll be at 0, 0. No matter what your scroll speed is. Set it to 1. Yeah, you can enjoy slow note speed on this if you want. But okay, well I don't have scroll speed set up yet for this right now, but you get the point. It's at this position. Now what we want is we want it to be lower, which can simply just be done by offsetting it by this position. You can either add a value if you want it at the top, or if you want it at the bottom, you can subtract like 140. What I did is instead is just plus negative 140, which is exactly the same. Now if we do this, look at that, it's at the bottom, and so are the notes. Now, obviously you may have noticed this, but you may have noticed the notes are really fast. That much can be said. Now, what we can do is we can divide sort out time in delta time. This is what that is. This is delta time right here, this value. This goofy little quirky thing is delta time. So we can divide this by a number. I prefer 20 and then a note speed. And you can then put that onto the offset. Look at that. We have a slower note speed. Divided by a lower number, we have a faster note speed. A lower number, say I want to divide it by like, 3. Ooh, we're feeling risky tonight. Look at that. Different note speeds, still the same timing. Okay, I'll go into why that was weird like that in a moment. But so I'm going to divide it by 20. And now I want this customizable. You can either skip this and just use this right here. I'd probably divide it by like 5 or something like that if you're not going to let people change it like a psychopath. But say you want to let people change it. Well, we have this variable that's note speed. It's a slider. Don't ask why I have it set to 40 or able to go up to 40. I don't know why you'd want it to go up to 40, but you can. So you're just going to plop this, multiply it by your note speed. Very simple. This is honestly the best way to do this. Look at this. See dynamic note speed. Now, I'll get into what this is here in a moment. But for now, let's go into what this is here. Print.game. This is done right before printing the notes. And what it does is basically just draws a line which shows where the notes need to be hit. And then we have this hit indicator, so we don't need to have your mouse down here. And so basically what that does, sets the pen color, sets the pen size, goes to the left side of the screen, which if I show the sprite, over here, we put the pen down, move over, put the pen up. And then we just go to the mouse position and stamp. After setting it to the right costume, of course. Next is, of course, note detection. Note hit detect. My beloved. So we also use delta time here. Here I use this instead because I don't want to fetch every single bit of data we need. So I just plop this up here. It's basically the exact same thing as fetching the note data and putting sort out time up here. It's important that you have it like this because if you do sort out time and you fetch note data right here, then it will, of course, not detect because it's detecting the last note up here, which then gets skipped by this. So this is the same amount of blocks. It's 2, 1 here, still the same amount. In fact, it's less. Saving 1 block, I know, I'm optimal. But this right here, it detects if it's the end, and then this detects if it's over or not. No. Okay, never mind. Yeah, this detects if it's over. And so what we do is we just set index to a value, and then we get our time, which is really all we use. We set note hit. Here's no hit. Of course, this, call me crazy, it's the distance formula. Now, I know what you're thinking. What the fuck? Well, here's the distance formula broken down. So we have this value, which is delta position. Multiply it by itself, or square. So we have square of delta position. And we can do the same with y, which is what we usually do for distance formula. And then we add these two values together. I'm still cooking. Give me a moment. Now, what this basically is delta x squared, delta y squared, add that together. What we do next, take the square root of this value. And, well, you may be thinking, what if we're not doing the y value? We're not doing the y value, so we can just remove that. And now, this is still a lot of blocks. It's really long. We don't like that. That's not pretty. We do the square root of this value. It's 240. Yeah, we got the point. But what this really does is we have a negative value here, which then gets multiplied by itself, which turns it into a positive. And then we take the square root of itself. And so if we multiply something by itself and then take the square root of it, it's the exact same thing as absolute value. Boom. Let me cook. See, let me cook. So what we do is, if it's in the range, we change the combo by 1, change the score by 100, and start a sound. Then, what happens afterwards, delete the note. What this does, it just deletes item index of chart.time, chart.position, chart.costume. Then we stop the script, and we don't change index here. If we change index here, we'll skip a note. We don't want to do that. Now, if we don't follow this, we'll change index by 1 and go to the next value. The reason why we don't want to change index by 1 is because the next note will now be the same index value. Now, if we were to test that, of course, whenever it's in the right position, I had offset issues. This is why I used to blink sprite. See? Alright, now, something you may be wondering, if I, like, I can, of course, play the map normally. If I leave it AFK, you see the notes delete and they count as a miss. And I break my combo, lose score, whatever you wanted to do. I decided for this style of a game, I would put this in print.note. Usually, you would do it in note hit, and you would detect it there. Here, since we already have store.time, it's less blocks. We detect if the combo is greater than 9, this is useless right now. So what we do is if our time value is less than -75, which gives you reaction time. Now, of course, we want reaction time, no timing in our games for rhythm games. So set the combo to 0, of course. Delete the note and then change index by -1. We delete the note, of course, because it's a miss. Then change the index by -1 because up here it's going to change it by 1 again. Then stop the script and prevent the note from being printed since it no longer exists. This is just an add sound effect if you have a combo that is 10 or greater and then you miss. You don't really need to do this if statement here. So that's basically exactly everything about printing notes. Let's go on to backgrounds. Backgrounds, my beloved. It's really just, you don't really need to do most of this shit. Here, I'm going to duplicate this out of the way. Well, really all you need to do there. You have a background with a dimmer. Put this in a forever loop. You can see it changes. Whenever I have a max background dim, it's black. No background dim, it's fully bright, and you can change this. I prefer like 75 or 80. May just be me, but that's the best. I added a minor parallax effect. If you know how to do parallax, you just increase the size. Here, I'll show sprite. You see like it moves slightly with the cursor. Not vertically, just horizontally. Actually, there. Slightly better script now. It's more interesting. Ooh. And then, of course, the background dim. Whoa, I did something wrong here. Oh, I have it visible, that's what. Yeah, a thing about a pen project, you want every single sprite hidden. You may have seen that already. Music's not hidden because, well, you're not going to see it. Same with Map Manager and Blink Sprite because, well, they're blank. Now, do I want to show that? Yeah, okay, so this is something I was going to put in part 2, but I'll just show it now so that way you can have ease whenever making maps for now. So, start by creating a new variable. Name it chart dot speed molt for all sprites. I'm going to show this variable, turn it into a slider, and change the slider range from 0.25 to 1.75. Default this value to 1. Do not reset it anywhere. It's going to always constantly be the same. And so the way we're going to do this is this will take chart.speed.multiplier and it will multiply the song speed by that. So say you have it at half the speed, the song will be half as fast. So we're going to do that by saying the pitch effect. Whenever you change the pitch effect, that actually changes the speed of the song too. We can show this later whenever we change the speed of notes as well. In this start music, duplicate it. Whenever I receive it, forever, we're going to set the pitch effect to a value. What will this value be? Glad you asked. It's a very simple formula. Multiply it by 120, and that's the left side. On the right side, get a division block, log, no, not that log of two values. On the right, insert 2, and on the left, put chart, not chart.speed.multi. Now if we play this, with, say we put it at half. Listen to the song. You see it's slower. And that's exactly half. How can we prove it's exactly half? Well, let's go into timer. And what we're going to do is we're just going to simply multiply it by chart.speed.multi. You have 1 times. Now let's start at half. Ignore the fact that I missed and that it's easier and I missed. Let's try it at 1.25. Now, something you may have noticed is the note scroll speed is affected by this. We can fix that by simply going down to where we print this and dividing the note speed by chart.speed.multi. If you want dynamic note speed, do not do this, like aka speed, velocity, and Osu Taiko. Now let's do 1.25. Decrease it. You see the notes still move at the same speed. Just they're further separated out on lower times. See the notes still move at the same speed. Now I'm going to keep this at 1.0 and I'm going to show you how you can basically make your own custom charts for now. So you will need to do a little bit of Googling. I don't really have an easy way you can do this in Scratch, but you're going to need the BPM of your song. I have this stored in a metadata folder right now. And so, never mind, I don't have it stored in the metadata folder. I'm going to have to go find it. Okay, so the song I'm using has a tempo of 158. So let's go to the map manager sprite. What can we do with BPM? Well, it's currently a useless value. But if we bring in a few blocks, we can make a formula. I have 2 multiplier blocks and a division. Put 1 here, put 60 here, put 1,000 here. Now, what value do we put here? Well, if you guess BPM, you're correct. So I'm going to put, for my song, it's 158 BPM. I have 37.746835443037.8. Okay, well, you take this value, put it in here, and now what can you do with this value? Let's bring out a bunch of division blocks. And so I'll use Osu as an example for this. We'll take these division blocks. Let's say we put 2, 3, 4, 6 in here. 2, 3, 4, 6. Now open Osu.
Welcome to us.
Alright.
Click the circles.
Osu. Options. Edit. I'm going to do the song that I have because I have it in this game. And this game has an editor. Let's go into here. Alright, I'm in a Discord call. I should leave that. Where's my fucking cursor? Okay, in here. Not song setup time. Yeah, 158 BPM. Now, you can use this Osu to time your offset, which I'll get into what offset is later. But basically, if this doesn't want to work, you see up here we have beat snap divisor. 1 moves it up like this. 2 moves it up like this. 3 up like this many. And 4, so on and so forth. It does an amount. You see we're at 1 flat? You see I move, wait no, hold on. Okay, I did that entirely wrong, 1 moment. Okay, so at 1, I move up 379. What value is this value divided by 1? Of course, 379. Let me keep cooking. Back in Osu. Two. 189. Here too. 189. You see where I'm going with this. Now, 3 and 4 will continuously do the same. Basically what this formula is you take your beat snap, which is up here, and replace this 1 with your BPMs, or beats per minute, in that weird formula we did. So back in here, we can take these values and we can basically just round them. Really, it doesn't matter. Or you can floor them. It does not matter. Flooring is probably better. I really haven't spent too much time testing that. But if we go into our chart.current value, say I want to add a note later in it. I'll copy this value. Say I want to move it 1 up. Well, I can add the current time plus this 64987 6499. So say I want to add one that's 1/3 up. Hold on. Well then, 662558. I'll just do 6626. Alright, now what I'm going to do is over here, I have encode chart, compress chart. Oh yeah, I forgot. I want it like this one. So 6499 -51 6626. Yeah, so basically what I did is I added it to our 3 lists from earlier: chart cost, chart pose, time. Now they're here. And so whenever we encode our chart into this, like here, I'll delete these values so it's what it's supposed to be. Encode chart, they're there. Compress chart, it's here. Alright, I'm going to delete this item. And now whenever you load it, it should be ready. So I do this. It's off time because I'm in a wrong sprite, whatever. So basically, it's like in a similar timing. Really, it's like 1 beat off. You get the point. But this is how you're going to be timing your notes and creating them. I'd like to end this off saying that the example project that I used here will be put in the description on my alt Scratch account, and if there's anything else you want me to go into more detail about in the full video tutorial, please let me know. That would be very helpful, as this is my first time actually making any form of a video. So, thank you for watching. Bye.